Hello 108 students, Mr. McCue here. We are going to wrap up section 9.7. We finally hit page 7. Kind of been a long section here, but I'm hoping our talking class notes will be able to give you some guidance here today. So we're going to work with example 6, and what we have here now is solving rational inequalities just like the previous example 5. We're going to go through our 5-step process, but this time notice we're working with an inequality that is less than or equal to -2. Notice that equal sign here in this example. Now, okay, so we realize we have to set them equal to 0, so we're going to -2 on both sides, and that's going to produce two rational expressions over here. And don't forget this -2 is still a rational expression because it can be put in the form of 2 over 1. Okay, now we need to combine that through the subtraction operation, and so we need an LCD, least common denominator, and every denominator has to be a factor, so we need to put the x plus 2 needs to be over here on the second RE, and we are going to multiply by x plus 2 down the denominator, going to stack it up in the numerator, so we got equivalency of 1 right here, and that way we're allowed to combine the least common denominator, the LCDs, and we're going to bring it back down here to say x plus 2. Now, as soon as you go here, don't forget this. What value of x will make the denominator equal to 0? And that's what the restrictions are about up here. So you want to remember that first thing you want to remember is there are under restrictions. X cannot equal what class? -2. And you set that equal to 0. X plus 2 equal to 0. Solve for x and you get x cannot equal -2. You have to remember that in these problems. Okay, with that said here, we're working our way down. We did the distributive property. Let me come back up here. You take a -2 times x produces a -2x. -2 times a +2 is a -4. Watch your signs. Next, you're able to combine x minus 2x produces -x. -2 minus 4 is a is going to be a -6. Okay, we've got those values all divided by the LCD x plus 2. Now we are ready to go ahead and work on step 2. So these take a couple little preparations here, but you got to remember the form has to be a rational expression on the left hand side, the inequality sign, and a 0 on the right hand side. Okay, with that, step 2 reminds us to take the numerator and set it equal to 0, which means you take -x plus 6 equal to 0, solve for x, and you get x equals -6. And these are going to be where your roots are at, where it's going to cross the x-axis. Now take the denominator, take x plus 2, set it equal to 0, and find x equals -2. But what's interesting is, well, that's going to be the roots. We cannot include that -2. Well, I've got solid dots here. You want to make sure that is an open circle on your graph. Okay, keep that in mind. It's kind of a bad habit to put those solid dots there. We're used to using our pencils on there. Make sure the restrictions means you cannot have x equal to -2 while you're graphing this parabola. Okay, now our challenge is we draw our x-axis. Don't forget that here. You might want to label it. 0 is over here on this graph. Remember, that's the y-axis. I know I overkill on it. But then with -6 included, we go ahead and draw the parabola. We can assume that it's going to open up, and we're going to have our 3 intervals. A is going to be on the outside, B is in the middle like we've done before, and C is on the right hand side. Notice where X is, it's in the C interval. That should be your clue to go ahead and test for the intervals. A and C are always going to be paired. In this case, they are going to be where you are above the x-axis. Okay, so now we come down here, we graph them. We know the vertex is going to be down below the x-axis, doesn't really matter, so we draw our pseudo parabola, and now we're going to go ahead and do step 4. We're going to test with x equals 0. We are in interval C. Again, I keep reminding everybody, watch the interval that you're testing. It's not always B. We put 0 in for x, and we have -0 minus 6 divided by 0 plus 2 less than or equal to 0, resulting in -6 divided by 2 is that less than or equal to 0? Remember, don't forget that question mark there. You're trying to answer this validity test. Is that a true statement or not? And finally, negative 3 is less than or equal to 0, so you've got a true. Therefore, interval C is your solution along with A. We can make that conclusion because they are pairs. And now we need to simply figure out the solutions writing our set notations. And we must always remember we have the restriction that x cannot equal negative 2 because it will make the denominator equal to 0. Okay, with that here, you want to scoot up to the top of the page, and in your notes you might want to come over here and kind of draw. I probably should have put a little divider line. This is the final solution here is x. You look at your graph, excuse me, let me just move that down just a little bit so you can see there. You look at your graph, you're doing interval B as your solution. Oh, I'm sorry. A and C are your solutions, excuse me, because when x equals 0, it satisfied the inequality, and we have the A interval is x is less than or equal to negative 6. We're talking from here going out, less than negative 6. The C interval starts at negative 2, but we cannot include it because it makes the denominator 0, and we're going on towards infinity. So x is greater than or equal to negative 2. You do not put that equal sign with that inequality because of the restriction, and your set of notation looks like this down below here. So you've got two components to it. There's interval A, here's interval B, interval C that we just talked about, and this is what you'll be putting in my math lab. Okay, folks, class, we have finished up 9.7 on page 7. That does it for this section. Mr. McCue out here for now. I'll talk to you later.